Okay, so we're just going to go through the first example from kinematics, which says that a particle moves in a straight line with displacement from your origin given by s of t equals 3t minus t squared meters at time t seconds. So we need to find our average velocity. And hopefully you guys remember that if you're looking at average of anything, it is, if we're looking at the average, oh sorry, that's too far up. If we're looking at the average of anything, say this is what our function looks like, it's probably not, but we'll just pretend. If we're looking at the average, it's just the straight line that joins any 2 points together. Okay, so we can use our m equals y2 minus y1 over x2 minus x1 formula, or we can also use our average velocity formula, which is f of b minus f of a over b minus a. Okay, which is exactly the same as this formula here. It's just written with slightly fancier notation for non-linear functions. Okay, so sorry if I just get rid of all of this. Alright, so with our average velocity, we're looking at, as I said, so if we're looking at A, got our average velocity is f of b minus f of a, oh, I'm getting better at this writing thing, over b minus a. Okay, and if we say a is 2, then f of a is going to be 3 times 2, so 6, minus 2 squared, which is 4. So that's going to be 6 minus 4, which gives us 2. Okay, b is equal to 5. So f of b is going to be 3 times 5, which is 15, minus 5 squared, which is 25. So that's going to be negative 10. Okay. So if we're finding our average velocity, f of b is negative 10, f of a is 2, over b, which is 5, and a, which is 2. So we're going to have negative 12 over 3, which then gives us negative 4, and our units are meters per second. Okay, so we're moving at an average velocity of negative 4 meters per second. We then want to find the average velocity in between our an interval of 2 and 2 plus h seconds. Okay, so this should be looking, you should be looking at this and thinking about first principles derivatives, because that's essentially what we're doing. Okay, so if we've got 2 as our t value, we know that s of 2 is equal to 2. Okay, and if we have 2 plus h, our s of 2 plus h is equal to 3 lots of 2 plus h minus 2 plus h all squared. And we can simplify that, and that's going to be 6 plus 2h, sorry, 6 plus 3h minus, hang on, this has gone small, I don't know why. So 6 plus 3h, and then minus 4, minus 4h, minus h squared, and they're all negative because that's negative out the front there. Okay, we can simplify this a little bit. We've got 6 minus 4, that's going to give us 2, and 3h minus 4h gives us negative h minus h squared. Okay, so we have that here. Alright, so then if we want to find our average velocity again, that's going to be f of b minus f of a over b minus a. Okay, and f of b is 2 minus h squared minus 2. Okay, so 2 and our 2 plus h, which is over here, and b, which is equal to 2 plus h minus 2. Alright, and then we can simplify this a little bit, so it's going to be negative h minus h squared over h. And again, we can simplify this again and take out some common factors here, and we're going to be left with negative 1 minus h. Alright, so from B, we found that our answer was -1 minus h. So then if we're looking at our limit, as h approaches 0 of our equation from B, I'm just going to drag that in there, we'll just pretend that I've written it in there. Then as limit approaches 0, we're just going to end up with -1. Okay, so our average velocity as the limit approaches 0 is equal to -1. Alright, now if we want to check this and find out if we want to get the right answer, we can take, we know that s of t, that our derivative of our displacement is equal to our velocity. Okay, so if we find our velocity by taking the derivative of s, the derivative of 3t is just 3, and then derivative of t squared is 2t. Okay, and then we can sub in v of -1. V of 2, I should say. V of 2, because that's our x value, should be 3 minus 2 lots of 2. Okay, so 3 minus 4, and that gives us -1. So we are good there. Alright, and that's the first example. Alright, I'll do the next one after this.